Hi, quick and dirty weekend project, actually. So we've had the question a couple of times whether we can do more than just normal classification. So I figured I'd take my Saturday and give it a shot to see what we need to do to enable regression in the studio. So what I have here is a small data set that I downloaded. It's not sensor data, but rather it's data about fish. So what we have is the length and the type of species and the width of the fish, and then we try to guess the weight of the fish. So the weight here is the label, and yeah, the data you see here is basically one frame of data. So it's 13 data points, and there's only one sample per file here. So that leaves us with, I don't know, probably 87 files or so. So cool. All right, what can we do with that? Well, so we can go to create impulse. This still looks like time series data because that's what I want to use it for eventually, but we don't have any data there. So 10 milliseconds getting the window length that I faked. So we have all the labels here, so just use raw data here, so no DSP. And we have a new learning block, and that is the regression block sitting here, so you can add that. So cool. So yeah, the raw data block does a bit of separation, but naturally this doesn't really yield much interesting information. We only have 13 different features and 90 or so labels. That doesn't really help much. But here's the cool part. So the regression block looks exactly like the Keras block, except that we have, instead of the minimum confidence rating, we have a maximum error percentage, which is I'm not entirely sure if that's the right approach, but that is the maximum error that we might have from the guessed value. Now that is a bit skewed because on small values that means you can have a very small error, and on large values you can have a really large error, which I'm not entirely sure if that's correct, or should we have an absolute value or something that scales. What is nice here is that the output layer is always one feature because it's going to be a scalar value. And yeah, same, we load a couple of default parameters and we can hit start training and we'll start running. So you'll notice here that we only have loss and not accuracy, and that's because we use different loss function. Here it drops down. It's still quite big, but that's because we have a mean squared error over the values, and these values are quite big already. But you see that the loss is dropping significantly fast. Same as everything else in Edge Impulse, we'll just store the performing model, we'll benchmark it against T of light and against Eon, and we also show the loss for both the quantized and the unoptimized version. So let's see if that actually works. So let's go to model testing, and so here we have the expected outcome, still the label. So when we classify, there we go. So this is the result that we get from the regression. If there's multiple frames in a file, there's only one here. We actually show the average, the min and the max here in the result window, so you have a bit of an idea of the range. And we color code as well. So as said, like the error here is only 6 points, but because we have a 20% point difference max, this is actually flagged as bad. Similarly, if you have a really big one, maybe somewhere like here 685, we predict 615, that is not too great, and here 700, 571, it's not that great either, so we need to rethink that a little bit. But here actually 80% of our samples are classified well within that range. And yeah, as with everything, we can just drill down into the classification here. So we see, yeah, so this kind of category stuff can go, but we see our detailed results, so it's times 0. We figured this was 245.17, and we show that as well here in the raw data field, so we can kind of look at some interesting things. What is around here? Beautiful. So that's regression. Does that work on device as well? Well, let's try it out. So with the WebAssembly view, naturally we can show everything except for the we don't really have an accuracy percentage or anything. We don't have a confusion matrix either, so that's something that we think a bit about. But we can compile with Eon. Same as always, so let's do a WebAssembly build. Cool, open that up, and So let's actually get the WASM build here, make a new file. I can actually copy that from a different project that I had. So this is a run impulse function. So now we need to pass in some data. So let's actually go back to live classification and load. That is actually the one that doesn't fail to classify, but it doesn't really matter. So 1306. So I'm gonna feed this into the quantized version. Actually, that's what we exported. So it's very little data, but the model successfully good at this. So we quantify, and now instead of an array of predictions or stuff out, we just get a single scalar value, and that is the result of our regression. So yeah, that's it. Yeah, regression backed by neural networks in Edge Impulse, and I plan to release this behind the flag, so you can try it out internally or with customers on some data very soon in studio.